Hello everyone, my name is Travis Arnold and I'm a designer developer currently working on the design systems team at Frame.io. Today I would like to talk to you about empowering more people to write UI for any platform using JSX. To preface, most of the code I will show today is still very experimental and there aren't any official docs or published libraries yet. First, I want to start with the current state of design handoff. Very few designers currently work in a medium that will end up in production. Many tools attempt to abstract design aspects into code, but fail to expose a declarative model that can be used as a source of truth. These tools are fantastic for doing illustration and icon work, but break down when we can't easily mix code into the process. Plugin systems available in these tools allow for writing code, but leave much to be desired. If we look at a typical workflow between teams, there's an inherent disconnect in our process. A designer creates something, making hundreds of decisions, then the work is handed off for a developer to implement. Finally, we ship an end product to production. Basic information about primitives like layout and hierarchy must be accessed imperatively and translated. This causes duplicated work and results in sources scattered across multiple tools. Not to mention it's a waste of valuable time. These decisions are encoded in one way or another, and we should be able to use them easily in the final product. So how do we fix this broken process and allow for proper synchronization between design and development? I think compilers might just be the answer. In the front-end community, we use compilers for everything. Babel, TypeScript, Prettier, ESLint, and soon the standardization of all of these tools in Rome. These tools help us be more efficient. We can enjoy new syntax features and compile them down to something browsers currently understand. In React, we've seen how even if the language doesn't offer a feature, we can utilize linting to guide how an API is supposed to work, as hooks work today. In a sense, compilers are liberating. They can take the burden off of API decisions, we can use code mods to rewrite an entire code base with new features, or help direct newcomers and teach them how our code should work. Similar to how compilers help us write code more efficiently, they're the perfect tool to help us map design to code. Other libraries like Svelte and Vue rely on compilers. How might we benefit from them in React as well as in design? Using static analysis, we can use the information from props to compile from one JSX source to another. One thing compilers can be good at is static analysis. Static analysis is the ability to determine how your code works without executing it. Using TypeScript as an example, the compiler provides rich information about the contracts we set up in our code, giving us the confidence to iterate quickly and easily. JSX specifically lends well to static analysis, depending on how it's written. Where we suffer most is we're free to do whatever we want when writing React. We can interrupt JavaScript wherever we see fit and pick various styling implementations. This causes problems for static analysis and keeps us from practically writing cross-platform code. By driving everything through props, we can open up a whole new world of possibilities. This brings us to style props. In almost every design tool, layout and style tokens are first-class concepts. Manipulating dimensions and space are done directly on the layer, and styles for that layer can use predetermined system values. However, for developers, each platform has a separate way of handling styles. Sometimes styles can be completely disconnected from the implementation, making them hard to reason about. This is where style props can help. Style props are simple prop definitions that control the styling of an element. By moving styling concerns to style props, we can get a better snapshot of the overall intent of how a component should work. Did you know? HTML3 had a form of style props. However, because the web was primarily focused on content, CSS became the standard way to target multiple elements for styling. Thus, style props were deprecated. Style props have excellent ergonomics. They're easy to get started with and quick to prototype, and can later be taken into production. Not to mention the concept maps really well to how design tools work. Designers work with high-level primitives already, drawing something like frames or text elements onto a canvas and setting props for the sizing, color, and other respective attributes. While styling isn't the only concern, how can we include systems like tokens, transforms, and variants into our props? To achieve that, I'd like to introduce you to a concept I'm calling compiler components. Compiler components marry design and development, allowing both disciplines to work cohesively together across any platform. This is done by using well-defined prop boundaries that can be statically analyzed, providing a rich source of truth for layout and styles. You can get started with compiler components quickly by using the create component function. This function accepts a configuration that describes how your component works across various platforms. In most front-end systems, we deal with the same problems: themes, transforms, polymorphism, variants, assets, and overrides. Although a bit meta, let's see how compiler components allow for best-in-class performance and developer experience. Just a note that overrides are still a work in progress in the overall system. However, we will see how we can use overrides when dealing with assets. Compiler components can configure a theme, allowing any prop to interact with your design system. This can be used during static analysis to get an overall picture of how your system is working. Sometimes you want to prototype things really quickly, or maybe you genuinely need a one-off. This built-in system allows you to work swiftly and track how your tokens are being used. Let's look at how we can map values to tokens using transforms. Transforms determine how prop values are mapped. They return an object of one or many values and work great for defining custom implementation details for your specific setup. Next, we have polymorphism, which is especially significant for accessibility when working on the web. We can use an as prop as popularized in recent React libraries to swap out the underlying element so our final output is semantic. Variation is inherent in UI design and development. The first-class variant system can be tailored to your needs when creating a compiler component. These are known as component and prop variants, respectively. They use transforms and can even influence the final rendered element through polymorphism. First, we have component variants. These are the standard configurations you may use throughout multiple props and are configured when defining your components. By using a compiler, we can effectively render optimized code for each platform. Next, we have prop variants. These are slightly different and don't require configuration, but rather allow setting different prop values based on theme properties like breakpoints or any Boolean value of your choosing. Again, using a compiler, we can optimize the component for the platform they are rendered to. In this first example, we can easily switch to a larger font size as the screen expands, targeting the tokens we previously set up. Next, we can see an example utilizing Boolean values to toggle an active background color on and off. When we get to asset management, things get really interesting. We move away from create component and instead utilize two global components, graphic and layer. These are responsible for communicating directly with your design file to extract assets. The graphic component allows us to quickly grab assets from a file, allowing further modification of props. When you want to target specific layers, you can use the layer component to add additional props, or use the power of polymorphism. In this example, we swap out the children for framer motion components, allowing us to animate them. Once an asset is in its final medium, we almost always need to make adjustments. We should be able to morph and tweak things instantaneously until we get the desired result. For example, the intro slide you saw earlier, I actually went back and tweaked my illustration after seeing it in the final medium countless times. Evolution is the difference between a good and great product, and is essential for the creative process. You should be able to hop on a quick call with your coworker and make on-the-fly changes, focusing on working together rather than tools getting in the way. UI should be as easy as possible to create and alter for both design and development. You can take this as far as you want to go. Imagine automatically getting an optimized icon set, using symbols for static SVG, and inlining markup only when you need granular control. Or you could fill out the description field in your Figma component, for instance, and use that as alt text. This creates a highly fluid channel between the designer and developer. Each person can iterate quickly and come to a resolution in minutes rather than hours or even days. This current implementation is only possible in Figma, but you can imagine if Adobe XD or Sketch ever offer a public API, we'd be able to easily change that implementation detail. In light of GraphQL, we can have a design graph, as Brent Jackson coined. Writing our components at a higher level lets us swap out underlying libraries, optimize code, and evolve our systems better. Next, we'll see how all of this sets us up for cross-platform development. SwiftUI and Jetpack Compose show that tools are heading for cross-platform development. Compiler components solve this issue in a performant manner for React. Because we have firm boundaries for how our components are supposed to work, custom visitors can be provided to determine how components are rendered to any number of platforms. As you may have seen earlier, our configs can define specific props and alterations for the platforms we're targeting. There's still a lot of work to be explored here, especially with asset management. It's now trivial to swap out the Web SVG visitor with a React Native alternative. The overall goal is to get up and running with your chosen platform by quickly understanding the core system. So what are some of the benefits of compiler components? They interact with your design system by default. They're cross-platform code for any target, native, CLIs, Figma, Sketch, and it's prime for MDX content creation. It's also implementation agnostic. For example, we can change to styled components or emotion, or even Bootstrap and Tailwind. We also can start to generate reports about our components and do linting to understand how our systems are being used. This also offers a best-in-class developer experience and user experience. We can get up and running quickly and prototype things, take them to production, and ship performant code. There are implications, however. Not everything can be compiled. Components that deal with child manipulation and other dynamic settings sometimes can't be analyzed, but that's okay. It's also harder to debug. At least right now, debugging is more challenging because we compile our code to a different source. We should be able to at least offer hints or offer additional tooling to help with this. Also, if you have an existing system, which you most likely have in place, we can use whatever underlying implementation we desire, like your favorite CSS framework, like we mentioned earlier, or a CSS and JS solution. Again, we can swap out these implementation details as needed. So why is this all important? It offers consistency, which makes it easier to scale, learn, and onboard new users. It also allows us to focus better on tasks that we have to do, like accessibility and animations. It's also fully declarative, which is liberating to express yourself rather than worrying about your tools. It also allows you more full concentration on your message or performance or the next big idea you have. Instead of a gap, the goal is a pit of success that anyone can enter into, not just design and development. Compiler components are future-proof. By keeping practical constraints, we create room for new opportunities. And by starting with code, we ensure that there will be a great editor experience built on top. Similar to how libraries like Next.js allow us to interop node development into our front-end code, I see compiler components enabling designers to truly interop into the development process. Leaning into compilers more allows us so many benefits. As David Rashid showed earlier, you can imagine a really great workflow when this is paired with other solutions like state charts. Design systems are about people. Enabling better tooling in our ecosystem allows us to empathize with one another better. Thank you so much to the open source community. The talks we saw earlier and the rest of this week will all take a lot of time and energy. Thank you to all of the organizers, presenters, and open source maintainers. These are a few of the projects and many more that have helped have inspired this librarian talk. So what's next? This is the tip of the iceberg. There's so much more to do here to get a better experience between design and dev. Handoff will exist until we can mend our tools into one another. Imagine the future you open your tool and seamlessly transition between code and design. You can focus on your own work while utilizing the requirements and strengths of other disciplines, allowing for more meaningful work. Cross-platform, at least right now, means anything that React can be rendered to, but in theory, we'll be able to support anything that generates JSX. Again, this is all still really experimental, planning for a stable release in the coming months. There are currently no docs and plenty of bugs, but you can follow along with progress at jsxui.com or my Twitter if you're interested. Fun fact, this whole presentation was made with the compiler in Framer Motion. Every demo you saw today was actual output from the compiler, and you can view the slides on the JSX UI website. Please note this site is currently only optimized for desktop use, and I plan to optimize it for other devices now that the compiler is working. Also, I'm testing spacer components extensively, so there's currently a lot of DOM generated in the presentation that I'm excited to try and optimize. Suppose we can write our code in this structured way. In that case, we might not need to render to the DOM one day. We can switch to a new protocol built for application development. Perhaps we're mixing and matching Canvas, but you're none the wiser. Thank you.
Yeah, thanks a lot, Travis. And I guess we move on to the discussion. So, yeah, exactly. How was the presentation created? So you just responded that, but yeah.
Yeah. ScreenFlow is what I used, and so you just crop you can record yourself as you record your screen, and so I cropped it to a circle and stuffed it in the corner there.
Yeah, there's somebody really excited about this JSX. So I think it can be really a good intermediate between designers and developers, because instead of getting this, like in the worst case, you get screenshots from your designer, and then you go and you tweak the pixels. That's sort of what you don't want. But if imagine you get JSX, then you just put JSX to your editor and go. So you don't have to work too much on that, at least.
Yeah, exactly. Yeah, so to really have like a source of truth there where you're actually a designer is manipulating JSX whether they know it or not is kind of the goal there.
And I guess it goes the other way as well. So as the developer, you notice, yeah, that can be better, or I should change that. So maybe it can map back to the design tool as well. So the developer goes and changes something and gives the JSX back to the designer, and the designer can do their thing. So yeah, that will be the thing. Let's see if there are any more questions or comments. Yeah,
exactly.
We don't need to. And of course, with tools like Figma, we will have this concern of how to deal with mobile or responsive layouts. So that's sort of how do you solve it? Because you have to. It's not like you design for print, that is one size, but then you have for the web you have to consider different sizes. How do you deal with it? I mean, what's your approach for it? What do you think of media queries against content queries and this kind of stuff?
Yeah, so I think that's personally where we should lean more into code, and maybe Figma one day is able to handle those kind of things, but I really see design tools as more for illustration and icon purposes, because I think they really shine there. And treating and actually being more in code and using that as a source of truth somehow, whether that's using like the React Figma package, for example, or React Sketch from React primitives, and being able to render that directly to Figma and using it as a source of truth. I think there's still like a lot to be explored there.
So what are your plans for JSX UI next? What do you want to do next, or like what's the release plan, or?
I think definitely getting to some sort of alpha release. Most of the compiler was written in the last like 2 weeks, and so it was kind of all the ideas I've been working on over the last couple of years and trying to get those out. And so trying to get to that, and then I think building an editor on top of that will be the next goal. So I wanted to start with code and then try to see how building like a tool, like a sort of design tool on top of that pans out. Just because, starting with code first, I feel like you're in a good spot. So we'll see how it goes.
Yeah, I guess we can move to more generic discussion. So how do you see JSX UI working with Solid or Xstate? Do you see interlaps or overlaps between different tools?
Yeah, definitely. And that's my hope, is leaning into JSX, kind of like Ryan even mentioned, right? Like you can write JSX in Solid. So my hope is that these things could translate to any number of platforms or even frameworks possibly. And I think it pairs very well with things like Xstate as well. So kind of showing how those like variant props with like the Boolean logic, you could see placing like those Xstate like Boolean functions in there.
Yeah, it's sort of, for me, it feels like we start having the pieces of the stack of tomorrow in our hands. So we sort of know how to deal with state and state transitions, and then we know how to deal with rendering, and now we know how to deal with styling or design. So we sort of have the piece of the puzzle together, where somebody has to put the puzzle together, like somebody has to get the puzzle done. So we start having that very nice technologies, and I guess if it goes like this, we're developing in a very different way in a couple of years. But that's just my feeling.
Yeah, that's definitely my hope. I want to, kind of like Paul showed, like we can build a game. You can just kind of pick up these technologies and get going. At least for JSX UI, the goal isn't to be like an end-all be-all solution, but mainly those in light of like React primitives, you can take a text element or stack or these simple primitives and enter into the platform of your choice. So if you want to build a game and you need to build a UI in your game, you kind of already know how to do that. So yeah, it's kind of the goal.
How does accessibility and stuff play into your planning here?
So that's mostly, like right now at least, it's through that variant system. So I didn't really present it, I think, maybe too well, but as far as like having a heading 1 variant as an example, we can, once it's rendered to native, if you're rendering to React Native, we can mark those things as like the accessibility role header. So we know once it gets to native, that variant will be accessible. When it's on web, it uses polymorphism to render an H1 tag. Things like that. But we can write this like generalized solution that's hopefully easier to write tooling for even. So.